Hello, students. We'll start with the next chapters. This is chapter number 2, patterns. Last year, uh, we have seen about the patterns due to the repetition of shape in which there is shapes are repeated one after another. For example, square, triangle, circle, square, triangle, circle. So, such a pattern which is formed by the repetition of the shape is known as a pattern due to repetition or pattern by repetition. We have seen this in last years. Uh, Even the pattern due to increase in shape or by increase in shape means the shape goes on increasing the size or it goes on decreasing in size. A pattern which is formed, it is known as a pattern due to increase or decrease in the shape. We have seen about pattern due to increase in numbers means the shapes they are going to increase in numbers. For example, 1 to 3, 3 to then it comes as a 1, 2, 3, 4, 5, 6. So they become 6 afterwards. There will be 4 circles below this. So the number of shapes they are going to increase, and this is known as a pattern due to the increase in numbers. In the last years, in the fourth standard, we have seen about one important type of pattern which is known as a tiling pattern. Tiling patterns in which the shapes are arranged in such a way that there will not be gap in between the shapes. For example, a pattern which we see in the honeycomb is a perfect example of a natural tiling pattern. Now, in this year, we will see about pattern due to rotation. Pattern by rotation. You may have seen many of the rangolis. You may have seen such type of patterns, such types of design on the monuments. You have seen such type of designs in architect. So we need to study the patterns which are formed by the rotation of shape. So in this chapter we will study about different patterns that can be formed by the rotation of shape. What is meant by pattern due to rotation of shape means a shape is rotated about a point in a plane so that we are going to trace the same shape after same interval of rotation, same interval of angle, so that a particular another new shape will be produced. This is known as the patterns which is formed by rotation of shape. For example, in this pattern you can able to see that this shape T which is rotated from this angle to this angle, again from this angle to this angle, and from this angle to this angle, so that a particular pattern is formed by the T shape. Not only this, uh, an arrow is rotated from this angle to this angle and from this angle to this angle, and again it's pointing upwards, so again it is going to form a particular pattern. And such a repetition of shapes after a particular fixed interval gives a rise to the pattern which is known as a pattern by rotation. Before going to the rotation of shapes, let us dig down deep into the what is meant by rotation. Rotation means turning an object about certain point. For example, as shown in the figure, consider that there is a clock dial and there is a hand of a clock. The hand of a clock is going turning around the center of dial from 12 to 3, 3 to 6, 6 to 9, and 9 to back to 12. Or so this rotation of this hand uh, around the direction in the direction in which the hand of a clock moves, it's known as a clockwise rotation. On the other wise, on the other hands, when the hand of a clock rotate in opposite direction, for example from 12 to 9, 9 to 6, 6 to 3, it's known as a anti-clockwise rotation or counterclockwise rotation. So, what is mean by rotation of shapes? So, rotating any shape about any point in either clockwise direction or anti-clockwise direction is known as a rotation of shape. Now take an example of this hand of a clock. It is going to, suppose it's going to rotate from 12 to 3 in this direction, means in clockwise direction. So from, if the clock moves from 12 to 3, angle turned by the hand of a clock will be of 90 degrees, and this rotation of hand of a clock from 12 to 3 is known as a quarter rotation. Quarter rotation means it rotates through 90 degrees. So it's known as a 90-degree rotation, a quarter of a turn. It's also known as a quarter of a turn or a quarter rotation. Suppose the hand of a clock that then moves from 12 to 6. So this angle, you can see that it's a straight angle. This total complete angle is of 180 degrees, and will be, you can see that this is a half of a circle and this is known as a half turn or half of a rotation. So a hand of a clock may turn from 12 to 3 to 6, which covers the angle of 180 degrees, is known as a clockwise rotation. Suppose the hand of a clock rotates from 12 to 6 while going from 9, means 12, 9, 6, then it goes through one again 180 degrees, but this is a counterclockwise rotation or anti-clockwise rotation through 180 degrees or half of a turn. So half of a turn is 180 degree rotation, quarter of a turn is 90 degree rotation. Then we will go for rotation of hand from 12 to 3, 3 to 6 again, and 6 to 9, means it goes from 12 to 9 via 3 and 6, means a clockwise rotation. This rotation will be of 90 plus 90 plus 90, that is 270 degrees, and this is known as a 3/4 of a turn or 270-degree rotation. 3/4 of a turn. So very clear. 90-degree rotation, a quarter of a turn or a quarter rotation. Quarter of a turn or a quarter rotation. 180-degree rotation, half of a turn or a half rotation. And 270 degrees is nothing but 3/4 of a turn or 270-degree rotation. Now, if the hand of a clock moves from 12 to 9 to 6 to 3, means it goes in the direction opposite to the hand of a clock, and this will be a counterclockwise rotation. So hand of clock moves from 12 to 9 to 9 to 6 and 6 to 3. This will be again 90 plus 90 plus 90. It will be 270 degrees in counterclockwise direction or 3/4 of a turn in counterclockwise direction. Now let's go for the next figure. Again, consider a dial of a clock, one hand of a clock which is going to rotate the center of the dial. Suppose it rotates from 12 to 3 and 3 to 4. This angle, you can see that it's more than 90 degrees. So this angle will be of 30 degrees. So 12 to 3, it's 90 degrees angle, and 3 to 4, it's 30 degrees angle. So 90 plus 30 angle will be of 120 degrees, and this will be rotation by 120 degree in clockwise rotation. This you can see that third part of a circle. So 12 to 4, this particular part is 1/3 part of a circle and known as a third of a circle, third of a turn or a third rotation. Third rotation. So this is 1/3 of a turn or 1/3 rotation. So 120-degree rotation is 1/3 of a turn. So 1/3 turn or 1/3 of a turn is nothing but 120-degree rotation. Now consider that the hand of a clock moves from 12, 3, 4, 6. and to the 8. So we have seen that hand moves from 12 to 3, 3 to 4, 4 to 6, 6 to 8. This total rotation will be more than 180 degrees. You can see that as the rotation from 12 to 4 is 120 degrees, and from 4 to 8 same amount of rotation. So this total rotation will be of 240 degrees, and that will be in clockwise direction. So when the hand of a clock moves from 12 to 3 to 4 to 6 and 6 to 8, it will be the clockwise rotation. But this covers you can see that two parts of three parts of a circle. So this is known as a two-third rotation. So 240-degree rotation is two-third of a turn, or two-third rotation. This is also known as a two-third rotation. If the hand of clock moves from 12 to 8, this will be the one-third of a turn in anti-clockwise direction. And if the hand of a clock moves from 12 to 4 to 8 and back to the 12, this will complete 360 degree rotation, and it's known as a one complete turn. Now, let us see the rotation of some of the shape. So we can go deep down in the detail how the shape is rotated and how it will look like after the rotation. Now you can see that the arrow is at the shape with the point of the arrow on the upwards. If I rotate this arrow about the bottom line in clockwise direction, say through quarter of a turn, means a 90 degree. In this case, the point of arrow will be on towards right side, and you can see that the vertical sides of arrow now becomes the horizontal. So the first of all, when the arrow is there, it's look like this. When the arrow is turned through 90 degrees in clockwise direction, the shape will look like this. Further, we are going to turn the arrow about the center again through 90 degrees in clockwise direction. So the angle with the original position will be from 12 to 3, 3 to 6. It means half of a turn or 180-degree rotation. So now the point of arrow will be facing to the down, and arrow will look like this. Suppose arrow is turned through 270-degree rotation from its original position in clockwise direction. So this will be the position after the rotation, 3 to 6, 6 to 9. So arrow now pointing towards the left, and it will look like this one. So you can see that a beautiful pattern emerges out of the rotation of a single shape. If I said the arrow is rotated in counterclockwise direction or anti-clockwise direction through a quarter rotation or 90 degrees, it will be in the opposite of the rotation of hands, and this will be the 90-degree rotation. Now, if I say the arrow is rotated in through 180 degrees in anti-clockwise direction, so this will be the 180-degree rotation, and again the point of arrow will be downwards. Now we are turning this arrow at the bottom line or bottom center. Let's try to rotate the arrow about the center. Here I'm holding this at the center, and I'm going to rotate it through 90 degrees. Now you can see that the pattern which emerges by the rotation of arrow will be like this. So it is rotated through 90 degree. Again it is turned through 180 degrees. So arrow will be like this. And at this point arrow will be like this. So When it is rotated through 90 degrees or a quarter of a rotation, arrow will be pointed to the right. When rotated through 180 degree, arrow pointing down. When rotated to 270 degrees, that's three-fourth of a rotation, arrow will be pointed to the left. And again, a beautiful pattern emerges out of the rotation of the arrow. Now let's rotate T about its bottom. So T initially, your T look like this. When it's rotated through 90 degrees in clockwise direction, the T head will be to the right and it's lying down. When it is rotated through 180 degrees to the original position in the clockwise direction, T head will be downwards. If it is rotated through 90 degrees in anti-clockwise direction, the point of the arrow will be to the left, and again you can see a beautiful pattern emerges out of the simple rotation of the T. Now you might have seen this arrow on the road signs where it shows that sharp rightward turns or 90 degrees turn. So let's try to rotate this figure in clockwise direction. First, we are going to, so initial position will be like this. Now, I am going to rotate it through 90 degrees. So, now we are considering a center line, a center point on this line so that we can take a reference of this line. So, we are going to rotate this line through 90 degrees either in the clockwise rotation or in the anti-clockwise rotation. So, successive 90 degrees rotations we are going to make. First 90-degree rotation, again a 90-degree rotation. Next, again a 90-degree rotation in the clockwise direction. So, a beautiful pattern emerges out of the rotation of a simple shape. You maybe have seen such types of puzzles which has been asked in your competitive exams. So, to crack such puzzles, one must know how to rotate the shapes. So, let's go down and again we will see the rotation of different shapes. Let's try to crack this puzzle. Now, you can see that this arrow, it's pointing to the top right corner. After that, it's rotated through 90 degrees and now it's initially pointing to the top left corner and now it's pointing to the top right corner. Then again it's rotated through 90 degree and it's pointing to the bottom right corner. What will be the next one? Definitely in the next figure your arrow will be pointing towards the bottom left corner. Now you can see that this particular dot, it's in the right corner, and you can see that consider this square without any other figures, and we have rotated this square about the center in anti-clockwise direction or clockwise direction through 180 degrees. In this case, the dot will come to the left bottom corner. Again, if it is rotated through 180 degrees, the dot will come to the top right corner. Again, if it is rotated through 180 degrees, then it will come to the left bottom corner. So, next position, will be the dot at the bottom left corner. Now you can see, consider the square without any other shapes except a square, small square in the corner. Let this square be rotated in the anti-clockwise direction. So if I rotate the square in anti-clockwise direction, next position after turning it by 90 degree is the square will go in this corner, right upper corner, and after turning through 90 degrees, the square will be in the left corner. Even after turning through the 90 degrees in the anti-clockwise direction, the square will be at this corner. So this will be the possible next position of all the shapes. Now let us turn next shape, which is a circle and a pointed head. Suppose I say to rotate this shape through 1/3 of a turn in clockwise rotation. So 1/3 of a turn means we are going from 12 to 4. So first of all we will draw a reference line so that we are able to turn about this reference line. So taking the center of the circle as center of rotation, first position will be this with the arrow pointing to the 12. Now we are going to turn it through third of a rotation or a 120 degree of rotation. Is this 120 degree rotation? No, it's a quarter of rotation or 90 degree rotation. So we need to go further. And now at 4 o'clock, this will be the required position. Hence through next turn will be through 1/3 of a rotation. Again 1/3 of a rotation in clockwise direction means from 4 we are going to 8. So this will be the required position of arrow. So our arrow now will be pointing towards 8. Again 1/3 of a rotation in a clockwise direction will be this. If I say to rotate in anti-clockwise direction, first 1/3 turn will take it to the 8 o'clock, second 1/3 turn will take it to the 4 o'clock, and third 1/3 turn will bring it to the back to the original position. Now let us turn this some of the alphabets. We are starting with A. We are going to turn alphabet say about the left bottom corner. So first we are going to draw a reference line. It will give a reference point or a turning point about which we are going to turn the figure. So I am going to turn the figure about the bottom left corner. So this is initial position of A. Now I am going to turn this A about this center. So you can see now the A is pointing to the left. So next shape of A is like this. Again, if I turn it to 90 degree, so this is nothing but 180 turn about the original position. The original position this. Now, if I turn it through 180 degrees, this is a quarter rotation, half of a turn. Now you can see that E is pointing towards down. Three-fourth of a turn or 270 degree rotation, E will be pointing to the left. If I say turn A in anti-clockwise direction, now I will take this as a point of a rotation through 1/3 of a turn, 1/3. So from 12, I am going to 8 o'clock. So from 12, I am turning it to the black. This will be 9, and below that it will be 8. So your A will be pointing to this position at 8 o'clock. If I say again turn it to the 1/3 rotation in anti-clockwise direction, so from 8 I am going to 4. So your A now pointing towards the 4, and your new position of A will be like this. Say that turn through 90 degree in anti-clockwise direction. So we are having next alphabet B, which is S. We are going to turn it through by 90 degrees in anti-clockwise direction. So first for 4 times. For completing one turn, we have to rotate it through 360-degree rotation. So first will be 90, again 90, 90 and 90. This will complete 360-degree rotation turn. So first turn in anti-clockwise direction. So initial position was like this. When it is turned through 90 degrees, now it's slipping down on its back. So our new position of B will be like this, slipping down the resting. Now when I turn it through 90 degree in anti-clockwise direction, you can see that it's facing back with a big B in the top. What will be the next position of B? It will be again B facing down or lying down with its tummy down on the ground. So this will be the possible next position of B when it is turned to 90 degrees in anti-clockwise direction. Our next alphabet is F. It said that turn through 1/3 of a turn in clockwise direction for one complete turn. Means we are going to turn F for one complete turn. For every turn we are turning it through 1/3 of a turn in the clockwise direction. So again, taking the reference point this, we are going to turn it. This now is at 12 o'clock. From 12 we are going to 3. This will be a turn of 90 degrees and we are going further for T at 4 o'clock. Means first your F will be like this. When it is turned through 1/3 of a turn in clockwise direction, next position of F will be this. Again, when it is turned through 1/3 of a rotation in clockwise direction, now this line will be pointing to 8 and your position of F will be like this. So we are getting a beautiful pattern by just turning F in clockwise or anti-clockwise direction. More turning in particular interval. For example, if I turn it to the 6 o'clock, to the mid turns, again, so you can see that just turning F in clockwise direction or anti-clockwise direction, we are getting a beautiful pattern. Now again, next question is to turn through 1/4 of a turn in clockwise direction for one turn. Now we are having next alphabet as N. First we are taking the reference point here, and this is our reference line which is pointing towards 12. Now when it is said 1/4 of a turn, means from 12 to 3, that is of 90 degree. So I am turning it from 12 to 3. So initially N was at this position. Now after turning this, new position of N will be this, which is this line is facing to 3. Now from again 1/4 of rotation in clockwise direction, we'll take it from 3 to 6, and an interesting thing, you will see that N is looking as original it is. So there are few alphabets or few shapes which after turning either through 90 degree or either by 180 degree or any particular interval will looks like its original shape. They are known as a rotationally symmetrical shape. Means even after rotating them through certain fixed amount, they are going to look like as they are original. They are known as the rotationally symmetrical shapes. So we are having few certain alphabets. For example, N, O. Did X is a rotationally symmetrical? Yes. Alphabet X is also a rotationally symmetrical. So find out such alphabets which are rotationally symmetrical. One of the alphabet is N. So after that we are going to turn n from 6 to 9. So at this position you can see that it's looking like Z, almost Z, and it's again come to the original position, which is turned as looking like as 3 again. So you can see N and N, Z and Z. So N, we can say that it's a rotationally symmetrical shape. So it looks like as original when it is rotated through a fixed amount and at a regular interval. The easy way to turning a sheet is to draw on a page and turn it to the given amount. Next, we are having alphabet S with us. We are going to turn S. So first, we will draw a reference line. So we will able to turn it. So we are taking this as a turning point, the center of a dial. We are saying that we are going to turn it through 1/4 of a turn or 90-degree turn in anti-clockwise direction. So when we are saying anti-clockwise direction, we are moving from 12 to 9. So this is our 9. So initially your S was like this. Now after turning it, it is looking like this. If you are going to take the bottom half and upper half of S same as it is, you will find that S also shows a rotational symmetry. So it's look like same when it is rotated through 1 degree. Now if I turn it through 1/4 of a rotation, again in the anti-clockwise direction from 9 to 6, your S looks like this. If bottom half and upper half of S is same, it will give the same symmetry as original one. Again from 6 to 3, so your S look like this. If upper half and bottom half is same, then it will look like this. So again a beautiful pattern is emerging if I just turn S in clockwise direction or anti-clockwise direction.